All right, folks. So this is your first video tutorial of the year 2015-2016. We're going to do some work with dimensional analysis. So I want you to get a few things in front of you before we begin here. First, I want you to get this sheet out, which I gave you on Monday, August 31st, just that dimensional analysis how-to sheet. Kind of a quick one-sheet review of the method I've been working with you on. All right. Next thing I want you to have out is the sheet, the practice conversion sheet I gave you also on August 31st, okay, Monday. Have that in front of you. And of course, you want to have calculator, pencil, and any other notes or notebook, I should say, that you want to have in front of you would be great too. So pause, make sure you have all those things, and hit play and watch away. So what we're going to focus on today is we're going to do the first three problems from the dimensional analysis sheet. All the way through start to finish using our prefix table and everything as we go. Longhand showing all the unit conversions, etc. All right? So question number 1 states, a book is found to have a mass of 0.6321 kilograms. Calculate its mass in grams. So I'm going to just write that out, kind of shorthand. 0.6321 kilograms equals blank grams. All right, that's the problem I'm essentially trying to solve there. All right, so first step first. Okay, step 1 is we're always going to begin by putting our starting quantity in a fraction over 1 with its units included. So I'm going to start. I've got 0.6321 kilograms. 0.6321 kilograms over 1. Now, you guys have noticed that I'm putting this in table form. All right, that's the way I learned it back in high school, and it's kind of a faster way to write out the fractions. The vertical line means multiply. Horizontal line this way means we're dividing our numbers. All right. So the next step here is I go to my table. Right. I want to convert this to grams. All right. So I'm going to go to my handy sheet here. I'm going to find kilograms, which is my kilo column, which is 10 to the third. Okay. Grams in this case would be my base unit. So my base unit on that table, if you look at it right there, 10 to the 0. All right. So remember, what we do here is we take our difference in magnitude, right? So my difference in magnitude in this case between 10 to the 3 and 10 to the 0 would be 1 times 10 to the third power. That's my difference in magnitude, right? Now, the next step is we're going to go back to those rules we talked about in our very first PowerPoint lecture in class was, how do I know when I'm multiplying? How do I know when I'm dividing? So in this case, I'm going from kilo to grams, right? So from kilo to my base unit. I'm going to a smaller unit. I think that was rule number 2, which means we are going to multiply, all right? So going to be multiplying by 1 times 10 to the third. So that means it goes on top of my fraction. Okay? So I know that's going to go up there. Now, I also need to make sure I'm keeping track of units. So if you go and take a look at this sheet right here, there is a little rule right here that I highlighted for you. And it says, whatever unit is on top in step 1 automatically goes on the bottom in step 2. So what unit's on top here? Kilograms. That means I know kilograms is going to go on the bottom here. Grams goes on top. All right. Just to be 1 kilogram is equal to 1 times 10 to the third gram. That's how I read that. Okay. And my job right now is to show that cancellation of units. All right. So lots of you guys, when we were doing that first ChemQuest, was not real picky with whether or not you showed your unit cancellation. Right now, I'm not going to stick you to setting it up in a table form. If you'd rather do the 2 fractions, that's fine. But quizzes, tests, ready to hear this? You must show how units cancel. You have to show that units cancel, and you've got a same size unit on top and bottom. Kilogram, top, bottom, they cancel. The unit I'm left with is grams, and that's what I'm converting to. So whatever you're converting to goes on top, whatever you convert out of goes on bottom. Top, bottom cancel, grams is going to be my answer. All right? So now we can run that calculation fairly simply. All right. So going to be dividing by ones here, so we don't even have to do any dividing. We're just going to be multiplying straight across. 0.6321 times 1 times 10 to the third. All right. I'm going to write this out two ways. I'll write it in regular notation first, and then I'll also write it in scientific notation for you. So when I multiply that through on my calculator, I could get 632.1 grams, right? So if I just multiply that straight across, left it in regular notation, that's the answer I get. Or we could go 6.321 times 10 to the 2 grams. Those are both the same number. They're both a perfectly acceptable way to express a number like that. It's not a super big number, so I wouldn't dock you there for not using scientific notation. But remember, we get really big numbers, really small numbers, we're going to use scientific notation for those. All right? So that is number 1. Move on to number 2. Do some erasing. All right, number 2. Question is, how many nanometers are there in 8.06295 millimeters? So my starting quality is 8.06295 millimeters equals blank nanometers. All right. I'm going to go ahead and write my initial quantity as a fraction over 1. 8.0629 millimeters over 1. I'm going to write this out in table form because that's my form of choice. And I'm the one doing the work here. So now my job is to figure out my difference in magnitude. All right, so I'm going to go back to my magic table here, and we should find milli is 10 to the negative 3. That's my magnitude. My magnitude for nano, which would be that second to last one on that table, is 10 to the negative 9. So what is my difference in magnitude between those two? 10 to the 6th. All right, so that is my number, right? Now, I have to figure out, what do I do with that number? Do I multiply it or do I divide it? So again, I have to memorize those two rules. Rule 1, 2, if I'm going to a smaller unit, so I'm going from milli to nano, I will be multiplying, which means this factor of change goes on top. So 1 times 10 to the 6th over 1, right? Millimeters is here, that means millimeters goes here. And nanometers on the top. Cancel, cancel. All right? So I can multiply that out. Now, notice this is 1 times 10 to the 6th. That's a million. That means my answer is probably going to come out to a big number. All right? So I'm going to leave this then in scientific notation. Now, the beauty here is I don't even need a calculator. I'm taking this times a million. So that just means I'm going to go 8.06295 times 10 to the 6th nanometers. And there's my answer. All right. Now, it won't always be that simple, so make sure you know how to do scientific notation on your calculator. If you're not sure, talk to me. Call me over during class. I'll straighten that out. Follow my advice there. Get used to doing that properly. All right, one more. All right, we're going to try to keep this one to less than 12 minutes, so I'm going to rush through this one. All right, number 3 from that same sheet. Question is, calculate the number of centimeters there are in 6.245101 kilometers. So 6.245101 kilometers equals blank centimeters. Right? That's what I'm trying to solve for. How many centimeters is that many kilometers? All right? So starting quantity over 1 first. 6.245101 kilometers over 1. Right? I'm going to be multiplying that by a fraction of some sort. And so again, go to my handy table. find kilo and centi on my table. So kilo's up here, right, at 10 to the third. Centi equals 10 to the negative 2, which you find in that table. So my difference in magnitude between 3 and a negative 2 is 10 to the 5th. All right? So what am I doing this time? I'm going from kilo to centi. So once more, I'm going from a large unit to a smaller unit. So where does my difference in magnitude go? Top. 1 times 10 to the 5th, okay, over 1. Now, kilometers here goes top first. That means it goes bottom second, and centimeters goes on top. So again, I can do a simple multiplication on my calculator, or I could do this one in my head again. 6.245101 times 10 to the 5th centimeters is my answer. All right, now keep it in mind, right, when I go up the table instead of down, right, we do the same thing with our difference in magnitude. We would just be dividing by it instead of multiplying. That's the only difference. All right, so I hope you guys find this helpful. Make sure you watch it, make sure you take notes, make sure you have all this stuff in front of you. All right, we'll be collecting this one, or I'll be checking it off here in the relatively near future. Until then, keep at it.